Today we'll be talking about Saga, a new protocol in the Cosmos ecosystem serving for the future of the Web3 multiverse. This video is a review of the project based on its official white paper. No token price discussion, no financial advice, just a video review about Saga's goals, benefits, and tools. Saga is a protocol for automatically provisioning application-specific blockchains in the multi-chain metaverse, or multiverse. They're building this by re-architecting developer and end-user interactions with blockchains. Using shared security, innovations in validator orchestration, and an automated CI/CD deployment pipeline standardized across apps and single-tenant VMs, Saga makes launching a dedicated blockchain or chainlet as easy as deploying a smart contract. Their network is best leveraged as a scalability layer for Web3 infrastructure. Saga offers no upfront cost to launch a chain, predictable developer pricing for provisioning block space, automated deployment of a single tenant application onto its own chain, a dedicated shared security chain for a developer's application ensuring high throughput, no dependencies on other applications using Saga, easy upgradability, and congestion relief. In addition, Saga's unique token mechanism design enables interesting and flexible developer business models and end-user experiences that were not supported before in crypto. Saga does not charge network fees directly to the end user, leaving monetization instead in the hand of developers. Saga enables transaction fees to be denominated in any IBC-compatible token, not just the Saga token, even though the Saga chain serves as the back end. Saga's initial focus will be on gaming and entertainment chains. Saga believes that its innovations in blockchain, which ultimately opens the door to processing low-value, high-volume transactions at scale, will enable new classes of DeFi applications that were not previously possible. As demand for smart contract technology continues to grow, developers and end users are running into three main challenges: high and unpredictable gas fees, congestion and lack of flexibility, and upgradability, as applications have to share block space with more and more applications on the same chain. It's no wonder then that applications and protocols are outgrowing their chains and need to scale horizontally or migrate onto different chains. Axie Infinity and DYDX are some of the most recent examples that have chosen this path. From this inception, the Cosmos tech stack has sought to solve these problems by emphasizing the sovereignty. Each developer was meant to have their own dedicated chain and therefore block space to build on. However, deploying secure application on Cosmos has also been difficult, slow, and technically complex. Every application has to recruit, maintain, and coordinate between its own validator set, and so developers have to consider the multi-party dynamics of secure consensus that are not a consideration for builders on Ethereum, Solana, or any other monolithic layer 1. In addition, Cosmos aimed for maximum composability, which meant that while developers could customize application as they liked, they also had to deal with the complexity of working with many modules. They do not believe it is an accident that the Cosmos moment has arrived just in time for the Cambrian explosion in the metaverse. As Web3 leads growth in the gaming, entertainment, and fintech markets, greater demands will be placed on the robustness and scalability of the underlying chains and the end-user experience. Saga aims to be the protocol for this multiverse. Over the last few years, over 3 billion of gaming assets has been tokenized into NFTs. Yet this is just a fraction of overall gaming industry, which is predicted to be a $269 billion industry by 2025, close to 3 billion gamers worldwide. Meanwhile, art NFTs are less than 1% of the $1.7 trillion art industry. In 2021, musicians only captured 12% of the $42 billion music industry. Crypto protocols like Royal, Async, and Audius are addressing ownership issues and pioneering new value capture methodologies, resulting in millions of dollars being passed directly to musicians. As said above, we can see that main things Saga is about are banging last year's and will be exploding in the next ones. Onboarding the next generation of Web3 use cases will only be possible via infrastructure that can scale. The Saga mainnet is the developer's portal into the Saga ecosystem. Like most smart contracting platforms, the developer deploys their compliant smart contract binary onto the Saga mainnet. Once initialized, the Saga validators automatically provision a Saga dedicated chain or chainlet containing the smart contract. In essence, a Saga chainlet is a sovereign blockchain with a VM module running a single smart contract. Because each chainlet contains only the smart contracts a developer or team would like to deploy on a single chain, the developers has a flexible and usable deployment environment. For the developer, the deployment of a chainlet is easy as deploying a smart contract. Chainlet block space is not shared with any other application, leading to predictable fees. Saga is VM agnostic, which means developers can bring their own VM module to plug into their chainlet. Chainlet components such as VM module, SDK, and Tendermint core can be upgraded independently from other applications and Saga mainnet. Ultimately, Saga could also support other technology stacks down the line besides Cosmos SDK and Tendermint. One of the challenges of deploying a Cosmos-based application-specific chain is the complexity around securing the chain. Each application chain requires gathering validators, distributing staking tokens, and designing a token mechanism that helps secure the chain. Saga uses shared security to remove this barrier to entry. Every Saga chainlet is secured by the Saga mainnet validators using shared security like upcoming interchain security. Deploying a smart contract and provisioning a chainlet on Saga is intended to be a fully automated process. We can expect thousands of independent chainlets to be running at the same time. This means that Saga validators will need to be able to automatically manage thousands of independent binaries on their servers and keep up with the resources needed to maintain them. To facilitate this process, Saga will develop validator orchestration tools that will simplify the process of placement, scheduling, releasing, installing, and upgrading. Automatically spin up new binaries and server environments for each chainlet. Automatically schedule binaries to be executed based on chainlet subscription SLAs. Facilitate deployment of new chainlets on multiple compute resources. Monitoring tools for validators to ensure sufficient resources are available for provisioning new chainlet. One of the more difficult tasks for validators will be predicting the required hardware necessary to service the utilization needs of all chainlet applications. On the one hand, having too much excess compute resources is wasteful. However, not having enough resources may result in slashing due to computer SLA violations. Therefore, Saga's validator orchestration tools will need to help validators predict when new hardware resources will be necessary. They split the token economics into two conceptual components, the front end and the back end. The front end is the portion of the token flow between the chainlet end users and the chainlet developers. The back end is the portion of the token flow between the chainlet developers and the Saga chain. Splitting up the token mechanism into two independent parts allows for interesting usability benefits and value accrual for developers. Imagine a scenario where Uber hosts their mobile app on Amazon servers. The expected user interaction flow is as follows. End users pay Uber, then Uber pays Amazon for hosting their application. It is unusual to expect end users to pay Amazon directly. However, this is the norm in most smart contract platforms today. The fees from the underlying network are paid by end users, not application developers. This results in end users needing to custody enough tokens to pay for the fees and prevents developers from exploring interesting business models such as ad-based or freemium models. On Saga, end users of each application interact only with the chainlet, and all fees for provisioning chainlets are paid by the app developers. This front-end model enables developers to explore interesting monetization models that were previously not possible. End users are abstracted away from network fees and the developers can implement more flexible monetization methods. The developers can still implement fees per transaction. However, this model enables those fees to be paid in whatever tokens the developer wants. The fee tokens gathered by the developer can be any external token, like stablecoins, Saga tokens, or tokens created by the developer. This fee will accumulate in a wallet controlled by the developer. The developer may implement a subscription service where only whitelisted users may use the smart contracts. The developer can also choose to make their product free for end users with monetization coming from other sources like advertisements. In this scenario, the developer will need to set up some spam prevention mechanisms to prevent malicious users from utilizing the chainlet capacity purchased by the developer. However, this can also be solved via whitelist accounts. In Saga, the developer pays for provisioning the chainlet. The interaction flow is designed to be similar to how an Amazon EC2 instance is provisioned for web developers. In order for a developer to deploy a chainlet, a developer must subscribe to a fee deposit, which guarantees a specified level of compute capacity for a specified amount of time for the provided chainlet. The cost increases for higher capacity subscriptions, and there will be discounts offered based on the duration of commitment. Once the subscription is selected, the developers need to post the necessary bond in Saga tokens to provision the chainlet. In essence, the fee bond is a prepay account to provision chainlets and will be drawn down over time. At the outset, the network will provision free credits, akin to trial accounts offered by services like AWS and Google Cloud to allow developers to freely set up testnets or experimental chains. But these free credits will only allow for a limited amount of chainlet capacity for a limited time. Once the chainlet is provisioned, the end user can directly interact with the chainlet. The maximum utilization of the chainlet will be restricted based on the subscription tier selected by the developer. The subscription model prevents idle, unused chainlets from existing forever. The only requirement for maintaining the chainlet is the payment of the subscription fees. As the protocol depletes the fee bond balance, the developer must maintain a sufficient balance to pay for the subscription. They will also allow developers to stake the fee bond tokens. Provided the developer has enough Saga tokens staked in the fee bond, this could allow developers to potentially pay for chainlet subscriptions from the staking rewards. Low deposit balances can be replenished by developers or broader community incentives. But once depleted, validators may halt the chain and after a predetermined grace period remove the unused binary and underlying data. The fee generated from developers is intended to pay for the validator's infrastructure cost of maintaining chainlets. Saga incentivizes validators to offer the most competitive rates to developers through their validator selection mechanism. Traditionally, in Cosmos-based projects, the validator active set is determined solely by the delegation count. With Saga, we will use the delegation process to incentivize validators to lower prices for provisioning chainlets. Saga will use a form of auction mechanism to have the validators bid with the lowest price they are willing to offer developers to provision a new chainlet. Only the cheapest validators will be selected as the active set. The price to developers will be set as the rate offered by the last and most expensive validator on the active set. Over time, this validator selection mechanism will ensure that the price offered to developers is as low as possible, while ensuring that every validator is sufficiently compensated for their infrastructure costs. Only the best validators who can minimize costs will continue to be included in the active validator set. To be clear, however, all Saga chainlets will be validated at the full set of Saga mainnet validators, even though the identity of individual validators may change through this auction mechanism. This condition is necessary to maintain the security of the optimistic coordination mechanism described above. Since back-end fees are intended to be distributed directly to validators, the token stakers are compensated by inflation. Saga uses a simple inflation model where the inflation rate is determined by the total percent of locked Saga tokens. The protocol will target a specific staking rate by adjusting the inflation rate. Similar to other Cosmos chains, validators will set a commission rate of the inflation, the one from the delegators. This is in place to compensate validators during the network's early days when the fees may not fully cover their operating costs. In the long run, they're targeting an economic system where the entirety of the validator's costs and margins are fully covered by the fees. When that time comes, they expect the network to eventually target zero or even negative commission rates where validators pay delegators from their fee revenues to attract delegations. Saga has a native protocol controlled reserve, a pool of Saga tokens that the protocol controls. The protocol controlled reserve is intended to be used for Saga mainnet critical activities, including funding the trial credits to developers to get started with provisioning a chainlet for free, funding relayers for IBC activities, funding protocol level partnership where key technology partners such as virtual machine developers are paid directly, funding other common goods activities and features in the future that may be introduced on the mainnet, and burning to reduce total token supply to target a specific supply. The protocol controlled reserve will be initially funded at the token generation event, but will continue to be funded through a few potential types of tax imposed on the token system, such as percentage of end user fees, percentage of developer fee, and percentage of inflation. By controlling where the PCR taxes token activity, the protocol can incentivize certain behaviors while having fine-grained control over how economic accrual happens in the system. Saga's unique and flexible product design enables partnership models with other ecosystems that allow for accrual of value of these ecosystem tokens and communities even when Saga serves as the base chain. First, Saga could partner with various other Layer 1 blockchain ecosystems to offer horizontal scalability solutions while keeping the economics of the respective token intact. Imagine a scenario where a partner network is expecting a smart contract that will generate too much traffic in the partner network's mainnet. To prevent their block space from being too congested, the partner network could deploy the smart contract on Saga instead. The partner network can post the chainlet provisioning fee in Saga tokens to get the smart contract provisioned. The chainlet can be configured to demand end users to pay fees in the partner network tokens. This way, the end user's interaction flow is identical to the case in which the smart contract is deployed on the partner mainnet. The fees paid by the end user follows their front-end token model and get distributed to an account owned by the partner network. A portion of these fees can be converted to Saga tokens to pay for the chainlet subscription. The remaining balance can be configured to be distributed back to the partner's validators and stakers in the same method as smart contracts deployed on the partner's mainnet. Saga's token mechanism allows for accumulated transaction fees to accrue value to partner stakeholders. The partner also keeps their developers and end user pipeline, maintaining brand loyalty while scaling through Saga. A second method of partnership is a revenue share between the Saga mainnet and technology teams across the ecosystem. This structure covers cases in which developers are coming directly to Saga to build their applications. Saga is meant to be a VM agnostic chain, and numerous VM options will be available to developers who come to Saga looking for an environment to build their application in. Therefore, Saga will want strong technology partners to support and develop VM technologies on Saga. Saga can always use its protocol controlled reserve to pay and incentivize these developers to continue to maintain and support their respective VM options for Saga. More specifically, the developer chooses a VM environment and deploys a smart contract on Saga. Then they post the fee deposit that is needed to provision and maintain the chainlet. Saga will provision a chainlet for the developer that uses the native token of the VM for transaction fees. When an end user uses the application, they can call the smart contract directly on the chainlet and pay transaction fees in the native token of the VM. These fees accumulate in a wallet controlled by the developer. The developer can convert a part of these fees to pay for the required bond needed to provision the chainlet or however they see fit. Saga can also take a portion of the fees and send them to the network affiliated with the VM technology partner as revenue share, incentivizing value accrual for the partner's token. Saga's mission is to give developers what they need to build in the multiverse. Web3 has already evolved to the point where new infrastructure configuration and token mechanisms are necessary to keep up with the growth of the industry and incredible influx of the user interest, the potential of which is still untapped. Saga's unique network and token design meet this moment. For new developers, developers at established projects looking to grow, and the end user they all support, a new protocol needs to bridge to the multiverse. Your journey starts here.